Hello and welcome to this calculus video. Today we will be talking about logarithmic differentiation.
Math 112.
Today we are motivated by the question of how to differentiate the function y equals x to the x. We can't use the power rule because the exponent is changing, and we can't use the exponential rule because the base is changing. To differentiate this function, we're going to have to use ideas from implicit differentiation. Firstly, we need the derivative of the logarithm function. We can use our technique for finding the derivative of an inverse function to compute this, and we find that the derivative of ln x is 1 over x. Secondly, we need to remember our laws of logarithms. ln of a times b is ln of a plus ln of b, ln of a over b is ln of a minus ln of b, and ln of a to the b is b ln of a. We can now approach our function y equals x to the x. The trick is to start by taking the logarithm of both sides, ln of y equals ln x to the x. We can use the laws of logarithms to write ln x to the x as x ln x, so what was before an exponential is now a product. We can differentiate both sides of this, the left by implicit differentiation and the right by the product rule. We get y prime over y equals ln x plus x over x, which equals ln x plus 1. We want to isolate y prime, so we multiply both sides by y and get y prime equals y ln x plus y. That equals x to the x ln x plus x to the x. The process we just used, taking a logarithm of a function to simplify it before differentiating, is quite useful, and we name it logarithmic differentiation. It is particularly helpful when we have a complex collection of products, quotients, or powers that could be simplified using the laws of logarithms. When we have a function that looks like f of x to the power g of x, logarithmic differentiation is indispensable. We don't have any other tools. However, if we have a function with 6 different things multiplied together, we could either do the product rule a bunch of times, or use logarithmic differentiation. It is usually only faster to do logarithmic differentiation if the number of terms is very large. Let's do one more example. Y equals 1 minus 3x all to the power cosine x. Here we have a changing base and changing power, so we have to use logarithmic differentiation. Taking the log of both sides and bringing down the power, we get ln y equals cosine x times ln of 1 minus 3x. Differentiating gives y prime over y equals negative 3 cosine x over 1 minus 3x minus sine x times ln 1 minus 3x. Solving for y prime, we find y prime is 1 minus 3x to the power cosine x times the old right-hand side. That's all for now, folks. Today we recalled some properties of the logarithm and used them to develop logarithmic differentiation, which is a technique for simplifying a function before taking its derivative.
Math 112.